Have you ever wondered if a single element from the periodic table could truly replace the immense world-running power of coal, oil, and gas? I mean, it sounds like pure science fiction, right? But actually, it's the ultimate energy question we're facing today. We are constantly hearing buzz about this hero molecule that might just step in and save the planet. But as you'll see, getting there, well, it isn't quite as simple as just flipping a switch.
To really wrap our heads around the scale of the problem we're trying to solve, just think about our global energy consumption. There's a staggering, frankly massive dominance of fossil fuels. Your gas, coal, and oil. And they're sitting right next to this tiny, almost microscopic fraction represented by renewables. The gap is absolutely massive. Moving the entire world away from those towering fossil fuel dependencies is going to require an energy carrier that isn't just clean, but incredibly potent and highly versatile.
So, welcome to today's Explainer, where we're going to put that potential hero molecule under the microscope. We are exploring green hydrogen, the clean fuel of the future. We'll be looking at its immense significance, its clear benefits, and the very real and often dangerous challenges that come along with it. Green hydrogen is being framed by experts as the absolutely crucial alternative fuel for the global energy transition, and today we're going to understand exactly why.
Okay, let's dive into this. Here's our roadmap for today. First, the green hydrogen promise. Then, global race and local rules. After that, safety risks and blind spots. And finally, the road to standardization.
Starting with Section 1, the green hydrogen promise.
So what actually separates the green version of this element from all the rest? I mean, hydrogen is literally the most abundant element in the universe. But down here on Earth, we have to extract it. Traditionally, we've used fossil fuels to do this, which creates what we call gray or brown hydrogen. True green hydrogen, though, is a completely different ballgame. It's produced via the electrolysis of water using renewable energy sources like solar, wind, or tidal power. The ultimate goal? Net zero emissions. Strict standards, like India's National Green Hydrogen Mission, legally define it as having well-to-gate emissions of no more than 2 kilograms of CO2 equivalent for every kilogram produced.
Now, you might be wondering, why go through all this effort? Well, when you compare hydrogen to natural gas, the gravimetric energy density is just astounding. Hydrogen packs an incredible 120 megajoules per kilogram. Compare that to just 49 for natural gas. It is a highly efficient energy carrier by weight. But, and this is a big but, hydrogen can ignite in the air at a massive range of 4% all the way up to 75%, whereas natural gas has a much tighter window of 5% to 15%. So while hydrogen has this incredible energy potential, its extreme volatility presents some very unique handling challenges.
And this brilliantly illustrates where all that power is needed most: heavy industry. When we talk about decarbonization, we usually just picture passenger cars on the highway. But the real beast to tame is in the hard-to-abate sectors. Think heavy shipping, aviation, iron, steel, and chemical manufacturing. Batteries simply cannot power a massive cargo ship across the ocean or fire a giant industrial steel furnace. Hydrogen, however, it absolutely can. It serves as both a clean fuel that literally only emits water vapor and a critical raw material for these massive industries.
All right, moving on to Section 2, global race and local rules.
This immense potential has sparked a massive rush across the globe, but different regions are taking wildly different approaches. Let's take a look at Europe first. The EU has set some highly ambitious, binding mandates through their Renewable Energy Directive 3, basically aiming for 42% of industrial hydrogen to be renewable by 2030. But, as we all know, mandates aren't enough on their own. As the Hydrogen Council emphasizes, securing offtake, which means finding guaranteed buyers, is priority number one for project developers. They desperately need these buyers to justify funding multi-billion euro production facilities. Without guaranteed demand, the money simply won't flow.
But creating that demand has been, well, pretty rocky, leading to major fragmentation in the EU market. Get this, 26 out of the 27 member states actually missed the May 2025 deadline to write these targets into their national laws. Because of this, we now have totally disjointed penalties. If a company fails to comply in Germany, they face a 14 euro per kilogram penalty. But right next door in Poland, it's only 1.4 euros. And while some nations are focusing heavily on establishing a domestic hydrogen core grid, industrial groups across the continent are pushing back hard. They argue that moving too fast could destroy jobs and impact economic human rights. Neutrally speaking, this mismatched implementation seriously risks creating a divided, uncompetitive market.
Now, in total contrast to Europe's fragmented struggles, India has opted for a highly unified approach. They launched the National Green Hydrogen Mission straight from the top down and immediately paired it with specialized nationwide safety regulations. These are managed by the Petroleum and Explosives Safety Organization, or PESO. Basically, PESO acts as the single defining cornerstone for local compliance, making sure that storage, transport, and dispensing all follow one standardized rulebook across the entire country. To speed up adoption, PESO has streamlined the licensing process for hydrogen dispensing stations into a really clear step-by-step framework. It starts with comprehensive document collection and layout approval. Then, it moves strictly into product testing to ensure cylinders and valves actually meet code. And it finishes with an application process through a brand new online module launched in May 2025. This kind of transparency is specifically designed to ensure safe handling, prevent accidents, and really build that customer trust, which is just absolutely essential for a hydrogen economy to thrive.
Which brings us to Section 3, Safety Risks and Blind Spots. Now, what's really interesting about this is, why are these strict licenses so absolutely vital? It's time for a bit of a reality check regarding the physical dangers of hydrogen. Because it is literally the smallest molecule in the universe, it creates entirely new engineering problems. From a material standpoint, hydrogen is so tiny it can permeate the walls of metallic storage tanks. This causes embrittlement and blistering, which can lead to catastrophic structural failure. On the handling side, it's a highly diffusive, colorless, odorless gas that is incredibly prone to unseen leaks, risking devastating jet fires. And honestly, it's not just the physics. Human error during routine maintenance and operation at refueling stations remains a primary contributor to severe accidents.
Beyond the flammability and handling, there is also the sheer physics of storing it. We call this the volume problem. Even when you cool hydrogen down to absolute cryogenic temperatures to turn it into a liquid, it still requires 7.7 times more storage space than standard diesel fuel just to get the exact same operating range. This massive volumetric hurdle requires highly specialized tanks and creates steep economic barriers. It's exactly why countries like China are having to pioneer massive sphere farm storage architectures just to manage the high-pressure gas before converting it into easier-to-store things like green ammonia or methanol.
To mitigate these massive risks, regulators are really clamping down. Returning to PESO's rules in India, they enforce mandatory clear zones. These are precisely calculated safety distances to ensure that if a blast happens, it just doesn't spread. For example, during a 2026 safety audit of a green hydrogen facility in Gujarat, inspectors found that the facility's mix of horizontal-mounted bullets and high-pressure spheres didn't meet the strict clearance calculations. This forced a rapid, sweeping layout reconfiguration. These stringent space requirements make rolling out hydrogen refueling stations in dense urban population centers an incredibly difficult engineering and zoning challenge.
Finally, Section 4, the road to standardization.
So, how on earth do we balance the incredible promise of this fuel with its very real physical dangers? Well, let's move on and see how this builds in the real world through active pilot projects. India is currently leading by example here with several major operational sites. Down at the NTPC Kawas Township, they are safely blending 5 to 8% green hydrogen directly into the domestic natural gas grid used by households. Meanwhile, IOCL is operating a major purification facility in Gujarat, and Reliance Industries is actively running a hydrogen refueling station in Jamnagar. These aren't just concepts on a whiteboard, they are functioning operations proving that the technology and the safety regulations can actually work together hand in hand.
But local success just isn't going to be enough. Hydrogen needs to be a global commodity. The final hurdle is closing those international regulatory gaps. While pipeline rules are maturing, we desperately need unified technical rules for underground storage, air traffic applications, and intermodal ship-to-land interfaces to support large-scale imports. Continuous optimization of these technical rules is absolutely essential as our field experience grows. Because if countries don't agree on safety and purity standards for hydrogen and its derivatives, like ammonia, we risk a regulatory race to the bottom that could stall the entire transition.
Which brings us to our final thought. The potential of green hydrogen to decarbonize our heaviest, most polluting industries is absolutely undeniable. But the road there requires massive infrastructure overhauls, rigorous safety clearances, and unprecedented global cooperation. So the question is, are we prepared to navigate these extreme safety risks and pay the high economic price of standardization to unlock a truly clean future? It is a fascinating challenge, and one that will for sure define the next century of energy. Thanks for joining me on this explainer, and keep questioning the science shaping our world.